Hello, my name is Pisek or Benz. I'm from Kesdan. At Kesdan, we promise to bring you actionable insights about AI and generative AI so that you can improve yourself, your work, and your business. Today, we are in episode 16, and I have a very exciting topic to discuss and to share with you all. So, a lot of people have asked me about advanced features in Open WebUI, including tools, functions, filters, and pipelines. And to be honest, I needed to actually dig a little bit deeper into all these things to understand. And for about today, I'm going to share what I've learned. It's not going to be perfect, but I think it will get you started into the right direction of how to use all these things that Open WebUI has to offer. But before we get started, don't forget to subscribe to our channel, Kesdan by AI. We are on YouTube, LinkedIn, Facebook, Substack, and X, and also on GitHub as well. So, if you look into Open WebUI's website documentation, you will see this plot, definitely. And this is an attempt to explain what filters and pipes are, and you can get some understanding of how you can use filters and pipes. But again, this is a little bit vague for me, to be honest. So this is my understanding of how to use these advanced features. So let's get started with the tool. Tools are actually Python functions, the script that you define as a tool for the LLM to use. It's actually up to the LLM whether it needs to use a tool to respond to a user message or not. And this is as simple as it is a tool. It is a Python function. Filters are mechanics in Open WebUI that allows you to process, first thing, the user message, the incoming user message. You can process it. The application of the inlet filter can be detecting whether a user provides you with an improper message or toxic language. You can filter it out, or you can translate the user message to English, assuming that the LLM will perform better in with the English message. And this is the ability of the inlet filtered, right? And after that, the filter user message will be given to the LLM, which will create a response. And that response can be passed through the outlet filter, which again process this LLM response to satisfy the filter's function or capability, right? And this can be adjust the tone or remove unnecessary text, for example. Yeah, pretty much this is what filter does, processing incoming message from the user and processing a raw output from the LLM. Last thing is a pipeline. Pipeline is probably the most powerful extension of Open WebUI. It's connected directly to the user message. Inside it, it has filters. It can have inlet filters and outlet filters as well. And in between these filters, you can write or customize all your codes. You can ask an API to query to external website or external database, or you can external RAG, vector embedding database. You can have another LLM inside, or even like a system of agentic workflow functions in there. So it can go wild inside inside the pipeline here. So yeah, the pipeline will, when you enable the pipeline will inject directly the user message into the pipeline. You can process it, and you can then this will go through a lot of functions or a lot of things that you define inside the pipeline, and you'll get a response back. So yeah, it's an God Almighty extension for Open WebUI. And this is it for tools, filters, and pipelines. Now, I have skipped functions, and we will see what functions do in the next few steps. So let's talk about tool first. Tools is actually, as I mentioned, a programmatic functions that you write in a Python script that the LLM will see and decide to use. So basically, it's up to the LLM whether it needs or it wants to use the tools to provide answer to the user query or not. The LLM is responsible for preparing inputs to a tool, right? So it will need to prepare an argument that it would need to provide to a tool. So I will show you 3 tools that I made, and one of them doesn't work. The other 2 worked, so we'll get to see how, and I have an assumption or hypothesis why this doesn't work. So you need to come here to the admin setting, admin page or admin account of Open WebUI in order to see here. I'm in admin now. In order to see tools here, you will need to click Workspace, and Tool is one of the tabs here. Now, in order to add new tools, you will click a plus button here, and then you will get a template. So actually, it's good because you can see what needs to be done here. So pretty much you need to use class tools, and you need to have initiation definition process in there, and then you can put all the tools a function. Each tool is a function. You need to put each function inside this to make up tools, right? Now this one function, one tool or one function will get the username, an email, and ID from it's a good way to actually show you how to use this variable here. Now you can put other functions in there. So what I actually want is I want to create a function that are related and pack them up together. My example is this guy, date tools. Now in this date tool, I have 3 functions. The first function is about get the current time, and in defining the tool, you need to give it a good description because the LLM needs to know what this function or this tool is good for. So make sure in the docstring you provide a description, a short description, and you may provide a meaning of the return value in it. Now, if function has arguments or inputs, you need to use this format as well: colon, param, and the name of the inputs or the argument, and follow up with a description. For this one, I have 2 input parameters. This function actually calculates the duration between a given 2 dates, and therefore I have 2 dates as an input to this function or to this tool. Now, the last tool that I have in here is a tool that will get me the day of work from a given date. And this is going to be done by some Python library that is very meant for determining a date of week from a given date string. So if you're happy, you can click save, and if your code is correct, you will get a green light from here. And then you'll be ready to equip the model, right? And when you do that, you come to a model, you click create a model, and you fill in information like name of this model, give it a good description. Also, some short description of this model is about. You can select base model. Now, this is tool calling capability. You need to select model that are trained for tool calling functionalities or capabilities. Usually, you need a large language model, like a GPT-4o is a good starting point, and maybe 4o mini can do this as well. In my demo, I actually picked a 4o mini, and it sort of worked when I tried it. So yeah, select the model appropriately for function calling. You can write the system prompt. as you wish, and I recommend you do so. And last but not least, you equip a tool by put a check mark in the box of the tool that you want to equip the model. So here is my example, date tool AI. This one, I'm using GPT-4o Mini as a base model, and the system prompt is you will help users with dates, calendars using tools. And you have a checkbox over here. Make sure that this model knows that it has a tool. It will learn that this tool exists. Okay, now let's try this tool out. So maybe I will refresh my interface, just make sure that all the updated configurations got updated properly. So I am going to try my date tool. Well, first thing, let's check out the day of week. Day of week of September, maybe 25th, 2024. That should be Wednesday. That's correct. Let's actually toggle this. Well, actually, you should toggle this guy just to make sure that the tool got triggered properly, right? Again, day of week of September 2024. That should be a Friday. Now, did you notice that when it was using function, it takes a little bit longer to respond? Because I think there's a step, an extra step inside that it will determine whether this query we need to use tools or not. Okay, so let me try again. I am going to refresh this guy. Actually, no. Let me actually ask the durations between two dates. Now, days between September 25th, 24 and September 1st, 2023. It happens to be this much. I think that is correct, right? Yeah, so now you have seen how to use this tool. With this tool equipped, the model actually knows, get access to all these tools. Okay, I am going to show you about another tool. This tool is very, just for a demonstration, it's very quick. Here, this tool is a fortune teller, and I made a function that will always return future of a name, a given name, an argument is awesome. So actually I should do this, param name of a person to foretell. Now I want to actually show you the difference, actual difference between toggling the tool on and off. Okay, so if the tool get triggered properly, the model will receive this very short fortune telling, right? Okay, now here is the one that this is a model, the fortune teller model, that the base model is actually the ChatGPT-4 or the latest one. The prompt is you are a fortune teller, you get a name from the user or ask the user politely for a name of a first person to foretell. Once you get the name, you must use a provided tool or function to get future reading. You answer to the user directly as the tool answers. So yeah, we'll see if the model actually follows this. And in the tools, I select the fortune teller tool for this model to use. I can click and save and update over here. Okay, all right, let's get to the demo. Is this guy. Okay, so this tool is not enabled yet. So let me just use it without that. Hey, I give it hey. Now it's hello. I sense you're seeking insights about the future. If you share with me the name of the person you'd like to foretell about, I can offer you a glimpse into what lies ahead. What's the name? So that's my name, Benz. Here you go. So, Benz, let me take a moment to glimpse into the future. Your future seems veiled just for now. Perhaps you'd like to inquire differently, or as at later time when the stars are aligned. See, it has nothing to do with the actual definition of the function. As you see here, my future should be awesome, but it did not respond like that. So let me try it again. Let me try to regenerate this again. Thank you for sharing. The future is about to reveal. Right? It's kind of stuck. I think it's trying to use tool, but because tool is not enabled here. So let's enable this tool and regenerate it again. So regenerating this thing that's it. The future for Benz is awesome. So it makes a difference between night and day whether you actually toggle this tool or not in the actual chat. So for this tool, only equipping it to a model doesn't ensure that this function got called properly. You actually need to enable this tool inside the chat again. On the other hand, coming back to the date and time here, the model can get by. If I remember correctly, I did not toggle this tool on. The model can get by with some query, but in order to make sure that it gets correct answer, I'm sure that you need to enable this tool if you wish to get the correct answer. So as a concept here, you define a tool, and if it's different from what the model has been trained on, the tool function calling tool, it will work more predictably here, and you need to toggle this function to make sure that it actually takes place. Okay, now what I show you is the fortune teller using the ChatGPT 4o mini, ChatGPT 4o as a base model, and when the tool is not toggled, if you generate the response, it's actually stuck. It seems like it's calling a function, but because the function has not been enabled in this chat yet, it's stuck. It's waiting for the response. I found out the difference between ChatGPT 4o and the GPT 4o mini behavior in this sense here. So let me just go here. A fortune teller, GPT 4o mini. Everything is the same except that the base model is now GPT 4o mini. So for that, let's try Ahe first. Ahe is that we get, how can I assist you today? If you'd like, please provide me your name. Similar to what ChatGPT 4o version did. So now, if I enable the fortune teller tool, give it my name, it should be awesome, right? Yeah, my future is awesome. But what I really want to show you here is when I toggle this tool off for a GPT 4o mini, it's rambling. So it's trying to do, it's implementing its own solution. So this is somewhat like hallucination. And that's because in the system prompt, I explicitly mention that you must use a provided tool or function to get the future reading. So what I found here is the difference of instruction following between a GPT-4o mini and a ChatGPT-4o in the system prompt. Okay, the last tool that I have made is the math calculation tools. Is the failure case. So in this tool, I have two functions or two tools in there. First of them, the first one of them is two number arithmetic. So my idea is I want the LLM to extract two numbers from the user query and identify the operator, add, minus, multiply, and divide, and perform a calculation. And in this function, if it actually worked, I will give it the actual the actual code to actually run the arithmetic operations. But I found that no matter what I tried, I couldn't get this function to be called. Let me just show you. So if this function got called properly, the answer will always be 456. Another function that I put there is get squared, square of some value, right? If this function got called, the answer is 1, 2, 3. And for some reason, I couldn't even get the model to call this function properly. Yeah, I think this is my failure case. And if any of you have succeeded in doing math functions for this tool, let me know. Okay, first of all, my modeled is here, Math Tool AI. I have provided a GPT-4o out. Let's get the best one then, ChatGPT-4o latest. And the prompt here is, you'll help user with math-related questions. You must use tools to solve the question and answer strictly using an output from a tool, not from yourself. And in the tool section, I check the math calculation tool. And that's it. I saved the model. Okay, just refresh this for the freshness of the user interface. Now, come to the chat, select the modeled. Don't forget to enable the tool in here. Okay, now this is my argument, 10 plus 1. The answer, now it's doing something, it's trying to check for the function. See, it gets an answer on its own. It doesn't use a tool, because if it used the tool, it should be this tool, two number arithmetic, and the answer should be 456. So yeah, I don't know how or why, but it didn't seem to work. Square of 2. It answered on its own again. I think because when you come back to this chat session, make sure that you re-enable this thing again. You re-enable this tool and still it computed on its own. What I don't like about this is I don't want math to be handled by the LLM because it can hallucinate. Computing is probably not the LLM's strength, right? So among the three tools, the fortune teller tool succeeded most like 100% of the time, I think. The date tools somewhat works, somewhat got triggered. I still have questions about get there weeks, and you saw it got it without me enabling the tool. And the last tool, the math tool, failed completely, like 0% of the time that it got the functions here got called. And this is my hypothesis. The hypothesis is that when the query is could be very related to the task that the model will actually train it upon. Like the model can be fine-tuned during the instruction fine-tuning process, can be fine-tuned to do math and reasoning. And this could be a reason why the model thinks that it should handle the task on its own. That's my hypothesis. I have no way to verify that. But to me, if you are going to use tools, make sure that the capability or the ability that the tools will serve is quite distinct from the model, what the model has seen before, like fortune telling, for example. It's very specific and unique, and if so, then tool calling is likely to succeed. Okay, that's the first part about tools. Now, a tab actually next to tool is functions. So let's actually understand what this tab is about. Function tabs actually enable you to define your filters and pipelines or pipes inside or directly within the WebUI interface. But the drawback is that when you use this tab, functions tab, you cannot install new Python dependencies in it, and so your custom filter and pipeline will have limited capabilities. It will be limited by whatever libraries or packages that the Open WebUI library that you are running. So again, in this function is a quick way for you to deploy filters and pipelines inside the Open WebUI. And if you want to add a new functions or new filters or pipelines, you will click this one. And then you will get to see a template, and this is an example of a template. By the way, you can also find open source functions or even tools from Open WebUI community, and when you click this, you will open up a new window. Not this one. You open up this window, and you can actually browse or search for tools that you want to have. You can even have functions, prompts, and models in here, and you can follow how to download and equip it to your tools. All right, so we actually are going to use this. This is a filter. So before we actually get into this demo, let me just introduce you to a filter, right? So filter, as I mentioned, is a step that allows you to process the input message from the user and also process the output from the large language model. So according to the WebUI, Open WebUI documentation, filter acts like a middleware that takes place before and after triggering the LLM. And the application can be related to monitoring incoming messages, take logs, or count how many tokens. Like you can incorporate length views here for monitoring purposes. You can edit the content, such as translating to English, assuming that you think translating to English before the LLM sees the input give you a better performance. You can also filtering out some words in the user message. So yeah, everything is possible inside this. So filters that it can be deployed in the function tabs over here. So yeah, now we can come to this guy. So filter has a template as well. You need to use a class filter template over here, and you may or may not use vals. Vals are like inputs to a filter. You will be able to configure it outside of this script. And this one is necessary. This is not necessary. You need to have an initiation values here, and during this initiation you create a vowels value, and you will have an inlet function and outlet function, which will be triggered at the input and the output of the LLM. And this is a template that will teach you how to do it, right? So let's go back to my filters. So I took the template and modified a little bit. So in this example, I have a filter class. Inside that I have a val class. It has an attribute prefix. What I want this filter to do is to add a prefix to an incoming user message. So coming back to this page, I am working on this inlet filter only, and whatever user message coming in, I'll add a prefix to it. And the default prefix is create one stanza poem of, that's a prefix. So and I give it a name, prefix of X. And this will be the name of the filter. Okay, now here, and this is the init process. I initiate vowels value in here using the class that I have defined before. You can also modify it on startup, on shutdown, on vowels update, but I didn't do anything yet. What I did is only in the inlet function over here. So I get a series of messages from buddy, and I pick the last message. That will be a user query message. I have a helper function, get last user message, which is defined right here. Right? It will actually get me the last user message, as you can see here. And then I am going to update, add the prefix to my the last user message using this line of code here. Self bounds prefix, remove any trailing blank space, and append the user message to it. And this is my updated messages, which will then be used to update the chat history, the last message of the user history. And then this inlet will return a body, right? And that body, after it has been filtered, will be provided to the LLM. So you can imagine that right now, after going through all of these all of this filter, the LLM will see a string of create one standard poem of ... where ... will be replaced by a user message. Now let's test it out. By the way, for the outlet, as I copy and paste an example code from Open WebUI example, I don't want to do anything in the outlet, so I just leave it blank. So I just pass the body in and out without altering it. So I am saving this, and let's go check out the filter. So come to the new chat here, and you can come to the functions here. The function, you will have a list of the filters or pipes that you defined here, and you can enable or disable it with this button. And this one allows you to change the values of the valve over here. So I just keep it here and click save and refresh again. Just make sure that everything is up to date, and I am ready to get a new chat. So in the new chat, you are not going to be seeing the filters, because the filter will be applied using this. So let's go chat with actually, you know what, this is false. Scratch what I just mentioned. After you define the filter, you need to equip it to a model. So this is the model that I defined here, is a poem, In a poem, I select a base model as a GPT-4o mini. I give it a good system prompt. Well, maybe not that great, but just short system prompt. You are a creative poet. You will receive from a user about a phrase. Well, such as dogs or man flying, etc. Or you ask the user to provide one. An example here is cat or dogs near the pond or anything like that. And now you activate the filter. This is the filter that I wish this model will apply every time it has a user message to process or the LLM response to process. And then I click update. So this is the model that I have my filter enabled. Now refresh this page again and let's try that. Here, this guy. So here we don't need to do anything. The filter is not going to be shown there. All right, so let's do cats and dog chasing a mouse. Here we go. What we see here is that this is the response from this message, but at the back end, as I mentioned, this user message got processed, and in this particular case, it's been prefixed with create one stanza of blah blah blah, and this is it. In twilight's glow, the chase unfolds, a cat with stealth and a dog so bold across the yard. Through shadows they spring, a dance of mischief where laughter takes wings. Doesn't really make sense to me, but that's a one stanza poem for cat and dog chasing a mouse. So here we go. So this is how to use filters inside in an easy way, which is inside Open WebUI Functions tab. But as I mentioned, there is a limitation because you cannot install new Python dependencies here. So yeah, you need to use, you can only use the libraries or packages that Open WebUI Docker or the source code has, or the environment, the environment that you provide Open WebUI with has that packages. Otherwise, it will throw an error. All right, so this is it about functions and filters. Now, last but not least is the pipeline. Now, for pipeline, I actually encourage you to come to the pipeline GitHub over here, which is from Open WebUI pipelines. I recommend you download or clone the Git code here and study it. And the reason is that the documentation on the website is not sufficient enough, and you need to actually come to learn more from examples here. So this is the cloned environment. It's cloned folder here, and you have folders of examples in here, and we will see in this examples we have filters, pipelines, and scaffolds. So scaffolds contains is a way to make multiple pipelines work together. I'm not going to cover scaffolds today. We'll just cover filters and pipelines. So an example of a filters code that I want you to focus on or get a starting point here is the LLM translate filters. Now, what I think is a little bit messy here is that even though it's filters, they still use a pipeline as a class here. I don't know why, but it kind of works. Actually, in the in the page here, pipelines seems to be a superclass or a better implementation of filter, because pipelines or pipes also contain filtering features like filters inlet and outlet right here. So maybe that's the reason why they don't really be strict about the class they use for whatever it is, whether it's a filter or not. Anyway, in the filter example, this is one of the example here, is actually implement. Let me just quickly jump to the section that I want. Yeah, it only has inlet and outlet, right? It doesn't have pipe, so maybe that's why they call it a pipeline here. It has a function to translate, which will actually translate from a source to a target. It's actually used in the inlet and in the outlet. So here is what it actually uses. So you get the user message here. It will translate the user message from a source users and the target users, which are defined in the valve here. Now it's trying to automatically auto-select the user target, but translate it back to English. Okay, so yeah, this is the inlet. So basically, inlet is translating user the message to the English language, and then the outlet is again translating it back. So yeah, this is a good example for you to take a look for the filter for the actually the structure, both structure of pipeline and valves. Pipelines and filters. Now let's talk about filters. Filters, as I mentioned, is claimed to be the most powerful extension of Open WebUI, and this is because it allows you to do so many things inside it. It's pretty much writing your custom code as a black box. Open WebUI doesn't need to know anything except sending a user message into that black box of yours, pipeline, and process and get something back. So yeah, it's black box. So this allows you to do customization your code, right? You can do RAG. You can have your RAG vector embedding database hosted on cloud and send a request to get the documentation or the context back. The same way with the SQL, you can request SQL from a remote database and get the response back. You can define your own functions, your own agents, and use it inside the pipeline. You can integrate, you can use it as a way to use non-open AI providers like Gemini or Anthropic, and also basic functionalities, other functionalities like web scraping. It can be done inside this pipeline as well. So here we go. Inside this pipelines example folders, you can actually see integrations. The web Wikipedia pipelines are showing you that the ability to, you can actually use web request or API call, but the structure is like this. The structure of the pipeline is start with, again, the class and the valve and the init, right? Now you have on startup, on shutdown, and most importantly, the pipe. The pipe is responsible for all the magic that's happening inside. You can put your code inside, the custom code inside this guy. It will do most of the heavy lifting here. Now, pipes, this example in this file doesn't have inlet and outlet, but you can also do inlet filtering and outlet filtering functions in here as well. Now this is an example, a code example that actually in the pipe it allows you to execute a Python function, Python syntax inside this code here. An example for integrating with non-Open AI providers is in this folder, and this is example with Google. You have a way to define or call your model, Google model over here, but it's quite messy. You need to like process the chat history somehow, yeah, to be compliant with what the Google API calls is. So if you're looking into using other models rather than OpenAI or Ollama with Open WebUI, come to this example and study up. RAG, and as an example here, here is a RAG, so the engine is hosted somewhere in this thing. Sorry, the engine, it is local, but it's a way to show you that this is possible to do knowledge retrieval. I am going to show you a very basic retrieval using just even data date, but this is a basic of the bare minimum of using pipeline for implementing data retrieval. All right, so I actually recommend you clone the pipeline folder on GitHub and use it on your computer. I tried to use pipeline with a Docker before, but if you do that, it's quite troublesome to add pipelines to your Open WebUI. The reason is that you need to always come to admin settings and come to this pipeline, this page all the time. Let me actually let me actually connect it yet. Okay. So right now I am starting my pipeline server. Here we go. The pipeline should be here. So if your pipeline server run, it should be runnable by this this page here. So assuming that you are using Docker, right? Now, if you want to add a new file, you need to come here and select code, and you upload it. And if it's successful, you'll be here. And if it's not, you need to go back to your code, fix it, come to this page, upload again. So it's inconvenient. That's the least I can say. If you are using a Docker pipeline, pipeline in a version of Docker. So what I did here is I cloned the GitHub in order to be able to run and add my pipeline, my custom pipelines very easily. So when you write your pipeline in a Python file, you can just drop it into this folder, the pipelines folder inside this pipelines repo in here. And I have 3 customs examples here already. Now the first one I want to show you is the prefixer. It's actually a reincarnation of this guy. This guy I implemented inside the easy way functions, right? But for if I want to implement it with a pipeline mechanism, I have to do it this way. This is the way we are going to do it now. Okay, so oops. Here we go. This is my code here. I'm using the same structure. I'm using the pipeline structure. This is the helper function for me to get the last user message from a body of messages. The valves here is create one stanza poem, the init function, the name is now renamed to a prefix. And now inside the init, I initialize or I create the valve instance. On startup, on shutdown, and valve subject left empty again. Now in the pipe, you see, if I'm doing it as a filter, I will be editing here, inlet and outlet. I can do inlet and outlet here, but I did not. If I use the pipe, what I want to show you here is, if you just use the pipe function, what are you going to get? So pipe function, in the pipe function, I have a user message. Now this is another boilerplate here. The if get something, just use it as is. Your code is actually after the else here. So what I'm doing here is I am going to append the prefix to the user message, and that's it. I return to the pipe. Okay, now let's see what does this pipe do with this code. A prefix, a pipe. Okay, now when you are happy and you want to run the pipeline, serving it as a server, you do this. You run sh and start sh. Now to make sure that the pipeline is connected to Open WebUI, I'll come here, check this, and if it looks like this, it works. So that is connection. So to see your pipeline, you need to come to the chat. Pipelines are available in the model drop-down selection. So here, that's a pipeline I made. It has an external because it's a pipeline. The pipeline is external extension, pretty much. So this is a prefixer. If I give it a user message, this is what I get. Create stanza poem of cats and dogs. So yeah, just to remind you again, this pipeline doesn't have a prefix. I'm sorry, this pipeline, a prefixer, doesn't have an inlet process nor the outlet process. All it has is a pipe which gets triggered, and when it gets triggered, it only returns a prefix plus the user message. That's what you get. As you can see here, the pipeline, you can make it as stupid as you wish, as I have shown here, or you can put so much brain into it. You can have another LLM, a lot of agents that will do more processing inside this. For other examples, I think you can take a look in these examples to actually dig down into how crazy the pipe can get. So this text to SQL pipeline is going to get crazy because now inside this pipe, it has another LLM. It actually has a database that it will query. Oops. So yes, so pretty much you can get crazy inside the pipe. Okay, but to understand how the structure works, I don't want you to get so overwhelmed with all the details here. So for the structure of the pipeline, you need to use Python code, Python a file .py, define all the things you want, but make sure to use this structure class pipeline. Inside it has a valve, and you need to define init, in which you should give it a name. You must give it a name and initialize the valve in it. You can add other things inside here as you wish. You also have on startup, on shutdown, and on valves functions for you to play around. You can customize. You have a choice whether to include inlet or outlet filters, and you should use a pipe. A pipe is where all the magic will happen, all the customization code will happen. And as I mentioned, it can be as stupid as what I just showed you, prefix, or even more stupid, just pass a message out. Yeah, just pass a message, output message here, it will be fine. Or you can add the brain or any other processing as you wish. And whatever got returned here is going to be what you get as an output from this guy. All right. So now that it's live, actually you can come to admin page, go to pipelines here, and select the prefixer pipeline. You will be able, assuming that you don't want to come here and fix everything, you can go crazy. You can actually customize from this page as well. And if we have updated like so, when we get to this again, it should get updated. So as you can see here, the way to use about it is, keep taking turns. You can select other models to work on it. But yeah, that's not the key for now. But the key for now is here. Once you serve the pipeline and it's connected to Open WebUI, you can adjust your vowels from this settings, this page here. Okay. Now, as a second example, I would like to show you a very stupid data information retrieval system using pipe. I'm not going to really use RAG here. I just want to show you this can be done if you modified it to be RAG. Okay. The same way as before, we use a pipeline structure. The init function has a name base retrieval. I don't add any vowels in it, so you can skip the vowels. See, I don't have the vowels function. I don't use it, so just delete it. I leave the on startup, on shutdown intact. I create another function called create data dict, in which it actually will provide me a Python dictionary with two keywords, geisha and blue mountain, the name of coffee. And each of them will have their own value associated with the key. The value is a description of these coffee. All right, and here, okay, what did I just do? Okay, that's the data, right? And now I have a pipe. In the pipe, I will get a user message. And what I would just need to do is I am going to make a lookup, right? So now inside the pipe function, the pipe will now know the data dict because I created from this line. And if the user message is inside the key of this, if the user message is not in the list of the keys of the data dict, then I will just return cannot find a product. But if it's a key, I will return the value of that key, pretty much a description of the coffee. So yeah, this imitates a very basic function retrieval like RAG. If you are going to do RAG, you are going to implement it a RAG way, but you might run into a problem of versioning because you probably use llama index or langchain or other vector embedding database, and then you need to import, and I assure you that versioning is going to be very challenging. Okay, so that's why I don't want to get bogged down with that, showing this concept of basic retrieval with the pipeline. Okay, now this function, this pipeline should be live. yeah, is here, so I can actually use it. Oops, sorry, I need a new chat, I don't want that. So select the basic retrieval. Okay, if I say mango, I will get cannot find products in database. Only available products are geisha and blue mountain. Sure, maybe I'll just say geisha, and this is the description of the geisha that the pipeline retrieved it for me. Imagine that this can be the actual context that RAG system, Retrieval Augmented Generation, or Vector Embedding Database Lookup, give it to you. It could be that, or it can be an SQL result of the SQL from an external database that you have. So once you get that, and I think this is what is cool here is, now you can choose other models and ask it to do something based on this description. Let's say based on your previous response, create a short advertising, a short social media post to boost sales. Make sure to use emojis and hashtags. Here we go. So it actually knows that it needs to work on this guy. And this is because the whole page that you see here is chat history, right? And you can swap in and out of the data. So sorry, the swap in and out. You can swap in and out models or pipelines that you want. Pretty much it. I think this is quite powerful. So I can actually go back to data retrieval again and say Blue Mountain, and I will immediately get back that, and I can switch back to ChatGPT, combine, create a social media post that combined to for two coffee types above. And this should be able to give you a result that has 2 coffee in it, because now this GPT-4o has an access to the chat history before it, right? So yeah, this is about pipelines. They are easy for you to use, and so if you have a new pipeline here, you just stop the server, drop in the new file and process it, and then yeah, here we go. And that's the end of today's knowledge sharing, I guess. So in summary, you have now seen how to use tools, you know what functions tabs are, and you know the difference between tools, functions, filters, and pipelines. And hopefully this video allows you to enhance your workflow with advanced features of Open WebUI. So thanks again for listening to me and staying with me this far. Have a great day. I'll see you again in our next episode. Thank you very much.